When we first introduced this idea of having these angle rules or angle properties, we said that the idea is that we were going to use these properties, these rules, to build towards answering certain problem questions where we've got a whole diagram, some angles are given to us in the diagram and some are not. And the fact that the diagrams are not drawn to scale means that we have to use properties of angles rather than just measure the missing angles. And we've already seen a couple of those types of questions along the way. But now we're at the point, having gained all of these angle rules, that we need to start putting them together. The types of problem questions we've seen so far have used one, maybe two of the angle rules. We need to really start putting all of them together to solve these kinds of questions. And actually, more than that, we need a way of tackling these questions, a way of knowing what sort of things to look out for in the diagrams, of knowing how to use the information to help us, which angle rules we need to use in which situations, how we're going to set these questions out to make sure that we get the marks by giving the right amount of information. To do that, we're going to keep in mind these 8 angle rules. These are our main 8, and we've also got a couple of other shape ones along the way. It's worth remembering things like the word regular, certain types of triangles, say, that might help us. But these are the 8 main angle rules or properties that we have looked at so far. And if we were to look closer at some of those, well, they might give us some clues as to the kind of things we're going to look for in these questions. Some of them involve parallel lines, for example, in which case it might be helpful to look for parallel lines in our questions that we're doing. Some of them use certain shapes, triangles, say, in which case it might be helpful to look for them in our questions. And actually that gives us a start point for tackling any of these angle problems questions. Now, the very first thing we're going to do when we come to any of these angles questions, whatever it happens to look like, is we are going to ignore the words, which might seem like an odd thing to do. But actually, we're going to start with the diagram, because the diagram is going to be much easier to break down and help us understand what's going on. And what we're going to do is we're going to look at the diagram and we are going to pick out anything, and in fact everything, that we think might be important, key, worth noting, something that might have something to do with which angle rules we're going to be using in the question. We are not going to try and second guess. At this point, we're not going to try and start applying angle rules, but we are going to pick out things that turn up in these angle rules that might be useful in some way. So we're going to have a look at this diagram in particular to start with. Well, the first thing we want to notice, there are 2 angles marked on this diagram. There is a 38-degree angle marked up around A, and we've got an angle marked X at D. Now, presumably, X is the angle that we are going to be working out the size of. We might also notice that we've got these letters A, B, C, D, E, and F. It's probably important to notice that C, D, E, and F make a nice straight line, and A and B make a nice straight line. We also have straight lines between A and D, and A and E. Right, let's look a little closer at this, because this is where we can really start noticing things. We're going to notice, first of all, these 2 arrowheads. What do the arrowheads mean? Well, the arrowheads are used as a piece of notation to say that 2 lines are parallel to each other. And if we're thinking parallel lines, well, that's probably useful because some of our angle rules use parallel lines. Corresponding angles, alternate angles, all based around parallel lines. So it's definitely worth noticing that. So the line from A to B, and in fact the line from C through to F, this line along the bottom, are parallel to each other. So there are our parallel lines. More than that, this line here, from A through to E, is a diagonal. That is a diagonal line running between two parallel lines. The parallel line at the top, the parallel line at the bottom, diagonal in between. That's worth noticing, again, because that further ties into this corresponding and or alternate angle ideas. Next thing we're going to want to notice. I reckon it's worth noticing, because triangles are a gift to these questions, that there is, pretty big spot, a huge triangle there in the middle. Probably going to want to notice that. And in fact, we also know what kind of triangle it is, because it has these two dashes on there. Dashes are used to show that sides are the same length. If those two lines are the same length and they are two sides of a triangle, then we have an isosceles triangle. And in fact, if it's an isosceles triangle, two of the sides being the same means that two of the angles are the same as well. That's probably going to be useful somewhere in the question. The question is probably going to involve us finding angles in this triangle and using the fact that two of them are the same. We can also work out which two are the same, based on those two sides being the same, and we'll come to that in a little bit. With these questions, it is particularly useful, I think, to have highlighters and or coloured pens to mark some of these things. In fact, I'm also going to highlight the parallel lines there and the diagonal between them. How much or how little you highlight, well, it's kind of up to you. The more you highlight, that might be helpful for you, or it might be unhelpful. It might end up confusing things more. But I personally would certainly be trying to highlight triangles. I would certainly be trying to highlight parallel lines if I can, or at the very least picking things out. Right, now at this point, we then have a look at the words in the question. We reckon we've probably picked out everything that we can in this question. We've started to get some ideas about what kinds of things we might be using. We might well be using the triangle property, we might well be using the parallel lines properties, and we're probably going to have to use the fact that it's an isosceles triangle. If it's there as an isosceles triangle, it's probably important. There's no reason for it to be isosceles, otherwise it's probably going to be important to the question. But at this point, when we reckon we've spotted everything, we have a look at the words, because the words might just tip us in to any other things that we might have missed. So let's go through the words one at a time. C, D, E, F is a straight line. C to D to E to F, it's a straight line. We said that, we noticed that, nothing extra there. A, B is parallel to C, F. Well, we picked that out. That's when we circled the parallel arrows. A to B and C through D through E through F are parallel to each other, and we picked that out as well. And then finally, DE is equal to AE. And we picked that out as well. That's where we noticed the two same length dashes on there. And then the question goes, work out the size of the angle marked X. You must give reasons for your answer. It's not surprising that we were having to work out X. We expected that. And this you must give reasons for your answer means quote the angle rule, the angle property that we are using. Now there are various different ways we can go about setting these questions out. What I'm going to suggest we do to keep things neat is I'm going to suggest that we kind of split our page in half. And on the left hand side of this dashed line, we're going to write the angles that we're finding and the sums, the maths, and on the right hand side with each sum we do, we're going to write the rule that matches with it. There are other ways to lay this out. The key thing with these questions though is you have to be very, very clear about what you're doing. You have to be quoting the rules. If the question says you must give reasons for your answer, then you must, and there are marks available for that. If you don't quote the properties, at the very least, you lose, say, half the marks for the question. It is possible that you will only get marks in the question if you give the property. So you potentially are losing all of the marks for a question, even if it's correct, by not giving the rules. It depends on what the mark scheme is doing. It can often be quite difficult to know where to start with these questions. So there are really two main approaches for starting. The first is to work out the size of any angle that you can see that you can work out. Any angle that you can work out might be a good point to start because it might just clue you into where you need to go with it. By working that one out, you might think, oh, okay, no, I can see where we need to go with it now, and then you've got the ball rolling. The second thing to do would be to look at the answer and work out, well, what other angles might I need to know to get that answer? If we look at x, for example, to find the size of x, we are probably going to need to know the size of this angle here, because the two things together set at a point on a straight line and make that 180-degree half turn. So we're probably going to need to work out this size angle inside there. Now that is one of the angles inside the triangle. So we're probably going to need to work out the other angles inside the triangle. Two of them are the same, we know that because it's an isosceles triangle, we've talked about it. But we need to know the sizes of the angles inside the triangle, most probably. Now looking at this triangle, there is no way we're going to be able to work out the size of this angle here. This one we're going to use to find x. There is little chance of working out the size of this angle here. Clearly, yeah, it's next to the 38, but they're not making a commonly known angle. They're not together making a right angle or a half turn or anything like that. It is likely that we're going to be working out this angle down here. How are we going to work out this angle down here? Well, it helps that this angle sits on one of the parallel lines. And in fact, if we look a little bit closer, we might be able to see, slightly tricky spot, but we might be able to see that we've got this 38 here. We've got this kind of Z shape, and then we've got this angle down here. The B to A to E to D, this kind of Z shape. And if we're looking at this Z shape, then we are looking at alternate angles. So we can in fact label that as number 1. This is the first angle I'm going to find. Number 1 is 38 degrees because, give my reason, alternate angles. Now you can quote the angle name if you wish, the 3-letter angle notation. So this one here would be, for example, A to E to D, AED. It's the angle at E when you go from A to E to D. But you don't have to, and that's why I've labelled it with a number, because we're avoiding using that angle notation if we can, because it can be a little bit tricky, a little bit off-putting. Now I've found that angle as 38 degrees, I'm also going to label it as 38 degrees in my diagram, because I know that it's there. So that angle there, at E, 38 degrees, because it's alternate to the 38 degrees that we're given. Slightly tricky spot, but it is there. And hopefully picking out those parallel lines, and the diagonal in fact, has made that easier to see. We have one of the angles in this triangle now. Now this triangle is an isosceles triangle. So either this 38 degrees is one of the pair of angles, or this 38 degrees is the other angle, the one that's not part of the pair. Well, really then, we need to know which two angles in the isosceles triangle are the same. Let's find out. To work out which angles are the same size in an isosceles triangle, we point to the two sides that are the same. We then point to the angle where they meet. The other two are the same size. So these two here are the same size. We now have everything we need to be able to work out the size of those other two angles. Why are we doing that? Because one of them sits next to the x. So our step 2, and this is going to be this angle down here, step 2. We're going to do 180. We're going to take away the 38, and that's going to leave me with 142 degrees. And then I am going to do 142. Divide it by 2, because 142 degrees is the sum of these two angles that are left in the triangle. I'm going to divide it by 2, and that's going to give me 71 degrees each, and this angle down here is 71 degrees, as is this one up here. So I'm going to fill both of those in. I need to give some reasons for that. Well, first of all, I took the 38 away from 180 degrees. Why did I do that? Because the angles in a triangle add to 180 degrees. That's true of any triangle. And then I divided what I was left with by 2. Why did I do that? Well, I know that those two angles are the same. How do I know they're the same? Because it's an isosceles triangle. Final step then, we now have everything we need to be able to work out step 3, the size of x. X is equal to 180 degrees less the 71 will leave me with 109 degrees. Looking at the size of x on that diagram, that seems reasonable. That looks like it could be 109 degrees. Obviously, if we measured it, it wouldn't be because this diagram is not accurately drawn. But it seems like a reasonable answer for the shape of the angle there. We need to give a reason for this as well. Well, I took the 71 away from 180 degrees. Why did I do that? because angles at a point on a straight line add to 180 degrees, i.e. the two angles together made a 180 degree half turn. But the reason that we're quoting angles at a point on a straight line add to 180 degrees, we have found the size of the angle x and we have given reasons for our answer. Next example, and once again we are going to have a look at the diagram first, see what we can pick out, and then we're going to use the words to help us back up our findings. So if we're looking at this diagram, we have got, first of all, something we might want to notice, two parallel arrows. The lines A, B, C and D, E, F, G are straight lines, but they are also parallel to each other. We've also got these two straight lines A through E through H and B, F, H. They are also straight lines, but they are not parallel. There are no parallel arrows on there, and in fact they are diagonals to the parallel lines. Now that suggests to us that we're going to be using this kind of alternate or corresponding stuff, and we might also have a setup with the opposite angles as well. We've got three angles marked in the diagram. We've got a 53 degree angle at the point B, a 28 degree angle at the point E, and we've got an angle labelled with an X, which is unknown and is presumably the one that we are going to be looking for. It's also worth noting that between A, B and H, A to B to H is a quite large triangle. And there is also another triangle hidden in there, E, F, H, a smaller triangle in there that sits inside the larger one. Those two triangles are going to be important, but what I'm going to do is I'm going to highlight the straight lines, the parallel lines, and mark on the diagonals as well. I'm going to mark this one with an orange, and I'm going to mark this one with a green, so we can see the two different diagonals in there, and we can make notes about those as we go. Let's have a look at the words now and see if that gives us anything extra. A, B, C and D, E, F, G are parallel, we picked up on that. A, E, H and B, F, H are straight lines, and we said that they are diagonals cutting through those parallel lines. And then we're asked to work out the size of the angle marked X. We're going to assume that we have to give reasons for our answer on this question because it's more interesting as a question if we do. So let's divide our page into two so that we can be labelling each step that we do. Once again, on the left hand side of that line we're going to write down the angles that we're finding. On the right hand side we're going to write down the reasons behind it. These angle rules, angle properties that we are using to help us find the missing angles. This question is very much one that can be done in multiple ways. There are lots of different rules and lots of different approaches that can be used for this question. I'm going to go for one of them. I'm going to talk through one way of using the angles that we've got to find this missing angle X, and then we'll just talk around a couple of the other things we might spot at the end after we've done it. What I'm going to do is I'm going to use the fact that we are looking at triangles. And I'm going to say I have got the X, that's one angle inside the triangle. And I'm going to look at the big triangle, A, B, H. The X is one angle in the triangle. If I can find the other two somehow, then that's pretty good, and I can use that to work out the missing one. I'm going to go for this one here. I'm going to look at this angle here first of all, this other one at B, and I'm going to label that with a 1. I should be able to work that angle out, because that pink angle, number 1, I've just labelled, and the 53 degrees go together to make up a 180 degree half turn. So I could work out the size of that angle, 180, take away the 53, that will leave me with 127 degrees. Why? Because angles at a point on a straight line add to 180 degrees. And I'm going to label that in my diagram so I can see it there. Right, this next one. I'm going to try and work out this angle here at A. Now it's not immediately obvious how to do that, but I am going to notice that I could work out this angle here and call that number 2. How big is that angle there? Well, we have two lines here that cross in an X kind of shape. which means that those two angles are opposite. So angle number 2 is also 28 degrees because it is opposite this other 28 degree one at E. So they are opposite angles. And again, I'm going to label that as 28 degrees. Why is that useful? Because if I get my orange highlighter, I can now mark on this F kind of shape. And if we have a 28 degree angle here, then we also have a 28 degree angle here. Because they are corresponding angles. They correspond with each other. They sit in the same places, the same positions on that F shape. So this angle here, number 3, is going to also be 28 degrees because they are corresponding angles. And then finally, my step number 4. I should be able to work out the size of X. I can do 180 degrees minus the 127 minus the 28, and that will leave me with a value for X of 25 degrees, which looks reasonable. Why did I do that? Why did I take those angles away from 180 degrees? Because angles in a triangle add to 180 degrees. The fact that these two angles are both 28 tells us that actually there is another way we could do this. We could have, for step 1, found the 127 degrees here in the same way. We could then say that this angle here is also 127. Why? Because it corresponds in much the same way that these two do. 127 here and 127 here. They are corresponding angles. They both sit at the same position on a diagonal to two parallel lines. If this is 28 because it's opposite and this is 127, it turns out that this smaller triangle has the same angles as the bigger one. Just like somebody shrunk it down. So we could have the final step being the same, again, just with slightly different steps in the middle. We'd have a different corresponding angle rather than the one that we found. Different way of tackling this question, but ultimately using the same numbers and ultimately giving us the same answer. As long as your reasons match what you've done and match the steps that you've done, then it's fine to do any approach that you wish. Now this next diagram should look quite familiar because it's the one that we started this whole angles properties idea with. And we said that we would build up to solving this question. And yes, the time has come for us to do exactly that. Now we said at first that this question looked quite complicated, but we should now be able to break it down into stages. And rather than try and look at it as a whole, we should do exactly what we've been doing with the other two of these angles questions, and we should start to pick things out of the diagram, see what we can spot that might help us with this question. Well, let's have a look. Well, first thing we've got A, B, C, D and E labelled. There are 3 angles labelled within that overall diagram. We've got 120 degrees, we've got a 38 degrees, and we've got a 41 degrees, plus the extra 4th angle, the X, that we're presumably going to be finding. Things that we might want to spot in this diagram. Something that probably jumps out immediately is that it's made up of 3 triangles. There is a large triangle here that contains 120 degrees and 38 degrees from A to B to D. There is a smaller triangle here from B to E to C, and there is a triangle here at the bottom from D to E to C. There are 3 triangles that go in there. The fact that there are 3 triangles suggests that we're going to be using this idea of angles in a triangle somewhere, probably. The whole thing is made up of straight lines. And in fact, A, B, C, D, the shape around the outside, is a shape that we might well recognise. It is a parallelogram. A parallelogram has 2 pairs of sides that are parallel. So top and bottom will be parallel to each other, left and right will be parallel to each other, and if we look closer, we can see that we have got those parallel arrows marked on the diagram. We've got a parallel arrow marked here and here, from AD and BC. They are single arrows, so they are parallel to each other. We also have parallel arrows on the top and the bottom, so they are also parallel to each other. If we just look at the parallel lines, top and bottom, we might also notice, if we pick those out for example, that this line that runs through the centre of the parallelogram from B to D or from D to B seems to be a diagonal connecting the two parallel lines, and we've ended up with this kind of Z shape. So perhaps there's something in there to do with these alternate or possibly corresponding angles as well. The fact that we've gained a Z shape from highlighting this suggests that we might be using this alternate property, because that is the shape that we're looking for with that. But again, of particular note, this Z shape from the parallel lines in the diagonal, and it's probably also important to notice that we are looking at three particular triangles. We can highlight those triangles if you wish. I'm going to choose not to. They are fairly clear to see in this case, actually. But the triangles are there and are probably important in some way. Let's have a look at the words in the question. ABCD is a parallelogram. Good, we said that. Angle ADB is 38 degrees. A reminder about this angle notation. It's moved from the first to the second to the third letter. It's the angle at the middle letter when we go from the first to the second to the third. So it's the angle at D when we go from A to D to B, A to D to B, and it's the angle at D when we do that, which is 38 degrees there. BEC, B to E to C, and it's the angle at E, 41 degrees, and D to A to B, 120 degrees. Good. Calculate the size of angle X. You must give reasons for your answer. So once again, I'm going to divide my page into two. On the left hand side, I'm going to have my maths, my working out, my sums that I'm doing, and on the right hand side, I am going to have my reasons, my properties, my rules, and I'm going to number what I'm doing so that we can track it through as a process. Well, the first thing I'm going to do, I'm going to go to that triangle, that large one, ABD. Because we've got two angles given to us in that triangle, we could probably work out the third one. With this kind of question, this one particularly, it's not necessarily immediately obvious what we should do to start with. So I'm just going to find any angle that I can. And I can find that angle easily enough. And in doing that, it might tip me off to maybe where I need to go with the question. So my step one is going to be, I should be able to work out this angle here. Because I can do 180 less the 120 less the 38, and that will leave me with 22 degrees. Why did I do that? Why did I take those two angles away from 180 degrees? Because angles in a triangle add to 180 degrees. And I'm going to label that as 22 degrees in the diagram. Now, step two. What else can I find? Well, surely I could use that Z shape that I've now looked at. And if I say that that is 22 degrees, because it is, we've just found that, then surely this one will also be 22 degrees, because they're on the insides of that Z shape. They are alternate to each other. So this one, angle 2, can also be 22 degrees, because it is alternate. They are alternate angles, the two 22 degrees in there. Why would that be a useful thing to find? Well, partly because there aren't that many other angles that I could find in this diagram, particularly. But also, if we now look at where the X is, the X sits inside this triangle DEC. We have the X in there, we don't know what X is. But we now have one of the other angles. And that's useful. Because if we can find the third angle in that triangle, this other one here at E, then we can work out the size of X. So really this needs to be our third step. Step 3, work out the size of that angle there. How can we do that? Well, we might notice that it sits on a straight line. It sits on a straight line next to the 41 degrees. Which means that the 41 degrees and this angle here, the one that we are looking for, make a 180 degree half turn, and that gives us a way of working out that angle. 180 degrees less the 41 is 139 degrees. Why did I take it away from 180? Because angles at a point on a straight line add to 180 degrees. And this angle here is 139. I now have everything I need to find the size of x. Because step 4, final step, is find x. X is equal to 180 less the 139 less the 22, which comes out at 19 degrees. That looks reasonable for the x that's drawn on there. Why did I take those two angles away from 180 degrees? Because, once again, angles in a triangle add to 180 degrees. Looking at the diagram on this question, something slightly different should be immediately obvious. There are no known angles marked on this diagram. All we have are two shapes and an unknown angle. Now we can say something more about those shapes as well. We can say that the shape on the left has 6 sides, 6 straight sides, and is therefore a hexagon, and the shape on the right has 8 sides and is therefore an octagon, and they join, and where they join there is some sort of angle there. So actually, in terms of picking out information from the diagram on this one, there's not an awful lot we can do. We might have to actually turn to the words this time. The diagram shows a regular hexagon and a regular octagon. Well, we identified that they were a hexagon and an octagon. This word regular, though, is important. Remember, a regular shape is one in which all the sides are the same length, and in fact all of the angles inside the shape, all of the interior angles, are the same size. And if all of the interior angles are the same size, that means all of the exterior angles are also the same size. The question then asks us to calculate the size of the angle marked x, and we must show all our working. There are probably two approaches to this question, and I'm going to do both of them, just so that you can see both. I'm going to do the slightly quicker one first, but it takes more logical leaps, this one. Whereas the second one is perhaps more familiar on what we've already done. But this one is slightly neater. It uses an angle property. Now what I'm going to do is I'm going to just tweak this diagram a little. I'm going to extend this line here. This line. Cutting that angle x into two pieces. Why? Because now it might be a little bit more obvious what's going on with the x there. This bit here, which I'm going to colour in orange, is an external angle for the hexagon. So we've carried the hexagon line on, and we've found an exterior angle. If this is an interior here, then it's paired up with an orange exterior angle there. And I'm also going to mark this little bit of the x in blue. And this bit in blue is an exterior angle for the octagon. Because again, we've carried on a side and we've found an exterior angle. They are exterior angles because this is what an exterior angle is. Think back to the interior and exterior. To find or label those exterior angles, we extended each of the sides in the same direction, fanning out to get those exterior angles. We also know some other stuff about exterior angles. We know that a shape has as many exterior angles as it has sides. So 6-sided hexagon has 6 sides, 6 interior angles, 6 exterior angles, and the 8-sided octagon has 8 sides, 8 interior angles and 8 exterior angles. And we also know one key fact about exterior angles. We know that the exterior angles in any shape add to 360 degrees. Because these are regular shapes, that fact lets us find the size of each exterior angle in the two different shapes. So I'm going to label the orange bit with the number 1. Exterior angles add to 360 degrees, therefore the size of one exterior angle will be 360 degrees divided by, how many of them are there on the hexagon? Well, there are 6. So each one will be 60 degrees, and this orange bit here is 60 degrees. Why? Why did we start with 360 degrees? Because we know that Why did we start with 360 degrees? Because the sum of the exterior angles in any polygon will be 360 degrees. Step number 2. Well, we could do the same thing for the octagon, surely. One exterior angle is going to be 360 degrees, but divided by 8 this time, because there are 8 of them. 360 divided by 8, 45 degrees. Why? Why could we do that? Well, the same reason. Same reason for both of these. So the orange bit is 60 degrees, the blue bit is 45 degrees, therefore the overall size of x, step 3, will be 60 plus the 45 is 105 degrees. Now, because that approach that we've just seen required us to spot that we could split that x into 2 pieces, both pieces being exterior angles of the shapes, it takes a certain logical leap. It takes us being able to look at this diagram and say, that's what we could do. There is another way to tackle this question without needing to do that, though. And it calls back to something that we did when we were looking at interior and exterior angles. And we can still set this out, we can still work stuff out, we should still get the same answer. Well, the first thing I'm going to do, I'm going to take the hexagon. I'm going to make a little quick copy of the hexagon there. Doesn't need to be particularly amazing, but a quick sketch of a hexagon just so I can see what I'm doing. And what I'm going to do is I'm going to work out the size of the interior angles. I'm going to try and find this angle here. It's a regular hexagon, so I've drawn myself a hexagon. What can we do to work out the interior angles? Well, think back to what we did. We split this up into triangles. I'm going to go to each corner in turn, always returning to the original corner, and I've got 1, 2, 3, 4 triangles. So the interior angles will be 4 times 180, 720 degrees. There are 6 of them, so then one interior will be 720 divided by 6 is 120 degrees. Why did we do this here? Angles in a triangle, add to 180 degrees. And why did we do this here? Because it's a regular shape. And we found that this size angle here is 120 degrees. Now we could do exactly the same for the octagon. We could try and find this angle here. Step 2 then, I'm going to sketch myself an octagon quickly. Again, it doesn't need to be particularly good. Just a representative sketch. I'm going to pick a corner, I'm going to join up to each of the other corners in turn. By doing that, I should be dividing my shape up into 1, 2, 3, 4, 5, 6 triangles. So the interior total is 6 lots of 180 is 1080 degrees. And so then one interior will be 1080 divided by 8, this time because there are 8 interior angles in that octagon. That's 135 degrees. Reasons again, angles in a triangle, add to 180, and why can we divide by 8? Because it's regular. We've now got that that is 135 degrees. What can we do to find the value of x? Well, we can notice that the 120, the 135 and the x make a full 360 degree turn. They are angles at a point. So my final step, step 3, x can be 360 less the 120 less the 135, all of which comes to 105 degrees, exactly the same as before. Y, angles at a point, add 2, 360 degrees. 105, exactly like before. And the final one of these questions is perhaps the weirdest one of all, because looking at this diagram, not only are there no known angles marked, there are also no unknown angles marked. There is no angle marked on there for us to find. There also isn't an obvious shape, particularly. I suppose there's the grey triangle in there, but it seems to just be a collection of some lines. So we really do have to read the words on this one. There's very little that this diagram is going to give us, other than the fact that there are some triangles in there. The diagram shows part of a pattern made from tiles. The pattern is made from two types of tiles, tile A and tile B. Both tile A and tile B are regular polygons. Work out the number of sides tile A has. Now, the first thing we need to make clear about this question, tile B is drawn in its entirety there. Tile B is a triangle. In fact, more than that, we are told that A and B are regular polygons. Polygons, remember, just shapes, different types of shape. Regular shapes, ones in which all three sides are the same length. So B is not just a triangle, it is a triangle where all three sides are the same size, all three angles in there are the same size. It is therefore an equilateral triangle. Tile A is a regular polygon. We do not know how many sides tile A has. We do know that it has at least 1, 2, 3, 4, 5 sides. It does not have 5 sides, because that shape is not complete. It also does not necessarily have, say, 10. You might be tempted to say, oh, well, that's half the shape shown there. We don't know that. It might be. It might not be. We're going to have to find out by doing some maths, by doing some angles stuff. Because there are no angles marked in here, but there is an angle that we can find. We can still use these angle properties. We should be able to find, for example, this angle here. How big is the angle there? Well, it's an interior angle for B. So this can be our first step, step 1. How big is that angle? Well, the three angles in a triangle add to 180 degrees. The three angles in this triangle are the same. So they must be, because it's an equilateral triangle, or because we're doing 180 divided by 3, they must be 60 degrees each. 60 degrees, and this angle here is 60 degrees. Equilateral triangle. We should now be able to work out these angles here. They will be the same. Why will they be the same? Because it's tile A on the left and the tile A on the right. They are both the same tile. They are both interior angles of tile A. They will both be the same. To work out that then, we should be able to notice that the three angles, the two interiors from A here and here, and the 60, make up a full turn, a 360 degree turn. So this is going to be step 2. 360 less the 60 is 300. And then dividing it by 2 for those two symmetrical angles will give us 150 degrees each. So this angle is 150 and this angle is 150. Angles at a point add to 360 degrees, and we divided it by 2 because they're clearly the same, they're clearly symmetrical. Why is that useful? Well, we now have an interior angle for tile A. If we have an interior angle for tile A, then we should also be able to work out an exterior angle for tile A. Because the link between interior and exterior, by definition of what exterior angles are, is that the two things, the interior and the exterior, should add to 180 degrees. So therefore, the exterior of A is going to be 180, less the 150 is 30 degrees. Because interior and exterior add to 180 degrees. One interior angle and one exterior angle add up to make 180 degrees, because this is clearly an interior angle of A. Now there is a key fact that we know about exterior angles, and that is that the exterior angles of any shape add to 360 degrees, and we know that one exterior angle on this shape is 30 degrees. So we just need to know how many 30-degree angles make up 360 degrees. How many 30s are there in 360? 360 divided by 30 is 12. There are 12 exterior angles. And if there are 12 exterior angles on this shape, then there must be 12 sides. So the shape, tile A, has 12 sides. Very different kind of question, this one. Quite challenging because it's completely different to the others, and you really have to know the angle rules well to know which ones you're going to be using. But that's why we've talked about it now.